Right. So for those who didn't watch the previous videos, right, I'm going to briefly discuss what I wanted to say about this thing about storing files and having a class that actually handles interaction between the entity class and the actual data file that that entity class needs in order to operate. Like if we have an entity on our system that's called account or movies, then we should have some data for movies in movies.json or movies.txt or any kind of file format, right? The same thing goes for account and accounts data.json. And for those who didn't see the previous videos, they don't really have to. If you want to utilize the time that you have, you can just jump to this video and see the implementation. But I'm going to give you like 10 minutes maximum orientation about what we did in the previous video to understand what's going on here, to understand what are we going to implement. So I said that we are going to have a class that is called, sometimes people call it DB handler, stored files, or database access. Oh, sorry. Database access object. This is the object that we are going to create that is going to have all of the data in our data file, right, stored inside a variable of that object's memories, instance variable like that. So the memory of any object of stored file that has been created will include the actual content, the whole content of the data file, right? So the memory is basically a volatile or a temporary variable that we would interact with via the account or the entity class, and instead of interacting with the actual data.json. Instead of dumping or loading the whole content inside the actual inside the actual entity class, which is in this case account. No, instead we are going to dump that content, load that content into a variable in an object of stored files, or an object of the DB handler class. See, I'm just going to use the names interchangeably. DB handler, stored files, they're the same thing, right? So the memory is going to be my actual interface, my actual variable that contains all of the contents in that data file. So whenever I create an object of stored files that I want to use as the main channel between the entity class and the data file, I'm going to send the actual file name into that object when I'm creating it, right? So the memory here, if I want as the account class, right? If I want to interact with the data.json, I'm going first to create an object of the stored files, and in that memory of that object, I'm going to send the data.json inside of it. So that object inside the account will contain the memory, which contains the actual data, right? Same thing goes for the movies entity class, for example, right? So if you want the entity class to interact with the data.json or the movies.json, we don't do this directly. We do this indirectly via the database access layer, which is in this case represented by the class stored files of the DB handler class. It's the same name, right? So if the movies want to interact with movies.json, we create an object of stored files that inside that object's memories variable, the content of movies.json are loaded. So whenever, as the movies entity class, I want to interact with the movies.json, I use that object that I have created of stored files, or I have created from the DB handler class, which contains a memory variable, which contains the content of the actual movies.json data file, right? So let me just do a quick sketch right there. Okay, so let's say that this is the account class, and the account class is going to be dependent heavily on the. Let me just take this a little bit further. On the actual data.json, I'm just gonna call it data.json. I know that I named it account data, so I'm just gonna call it data.json, right? If you don't understand what is a JSON file and why do we use it, please watch the essential videos about storing any kind of built-in data type inside a file. And that file, to be compatible with the stored data type, it needs to be a JSON file, at least in Python. Okay, so that data.json contains a list of dictionaries where each dictionary represents to me a specific type of person. Right, so we saw this here. We saw this here in the previous video. We said that data.json contains a list that has a dictionary, and that dictionary represents to me a record, a row in a table that is called accounts table, for example, or users table in the database, right? So this is every person has a username, password, and a reservation. Let's skip reservation for now, all right? Let's just say that we have username, password, and email. Okay, so this is the kind of dictionary we are dealing with. Let's say that we only have one person, one customer, which is the admin of the system. Let's say that his name is Ahmed, and password. Okay, and finally an email, right? So just a quick note about why did I choose the structure to be a list of dictionaries, or a list that contains dictionaries, so a list of dictionaries, right? So typically in a database storage, it's just a huge storage area that has tables, right? Tables for specific stuff. Like in a class diagram in UML, right? In a DCD or a class diagram, we typically refer to classes that are called entities, for example. We refer to entity classes or model classes, which is M from MVC or E from ECB pattern, right? We refer to these entity or model classes by what class in the system does have data that should be stored in a file, or that has data that should be stored in database. In this case, if I have an account or player or user, all of these are screaming to you that these are entity classes, because all of these has some data that should be stored in a file for consistency, right? If I want to create an account, first of all, I should have all of the users stored in some data file. So if I wanted to create some account, I want to check the database. Do I have that user? If I don't, then create the account. If I don't, then create that account. If I do have that user, then do not create that account, right? So that's the same thing for login, for example. If I want to log some user in the system, I need to check, is that user inside the data file that corresponds to the users, to all of the users? If he is there, then just log the user in. If he's not there, then do not log him in, right? Tell him that he needs to sign up first. So that's the whole point of storing data for users, in this case for accounts class in this case, right? So bottom line, any class that needs its data to be stored in a file, this is an entity class, this is a model class, right? Typically it's the same thing in a database, right? So if we're talking database here, and I know that you've taken the lecture about databases with Dr. Manar in the software design module, right? So if we have the same thing in that's the UML, right? The same thing in DBs or databases, right? So in database, if I have an account, right, an account entity, so I can represent this via what we call a table inside a database. Like I told you that tables or database, one database can store multiple tables of the same homogeneous tables, if you may say, like tables of that does some similar functionalities with each other, right? So we would have an account table in the database that will contain the same keys of the dictionary of each record. So the keys in a dictionary, the keys in the dictionary that we have inside the data.json are basically the type of columns that you have in your database. It's the same thing. That's why I structured that code in that specific manner, to be relative to the kind of structure that you'd have in an actual table in an actual database, right? So in this case, we have in this data file, for example, we have only one customer, one dictionary, right? That customer has a value of Ahmed, and it has a password of 123, and it has a specific mail, right? So a tuple in a database, or a row in a database, this is what we call a tuple, right? It's corresponding to a dictionary, to one specific single dictionary entry inside my list of dictionary inside my data.json. I hope the mapping is clear now. Why did I use list of dictionaries? In your chatbot, you're gonna have something like intents. Now, you don't have to have the intents scheduled or structured as list of dictionaries, but I just use that structure for typically because typically most of the stuff that you interact with the database with, it has the same structure. Like each dictionary should have the same key. Like each dictionary, each table, each column will have the same column. Or I'm sorry, each row will have the same column. Right? Only the values that are inside that dictionary or inside that table are going to change. Okay? So in your intent JSON, having this as a list of dictionaries a list of lists, a list of tuples that has a value, a single value on the right hand side and a multi-value on the left hand side, that's totally up to you. You are the one who should decide, you and your team, which structure will fit your searching algorithm that you will use to check the intent in your JSON file, right? So you want the algorithm, the searching algorithm, to be as fast as possible, as quick as possible. So what kind of structure do I need? Do I need list of dictionaries? Do I need list of lists or list of tuples that has value and a dictionary beside of it, or list of, for example, or list dictionary of dictionaries, something like that. So you are the one who decides this, with trial and error, of course, right? So you decide the structure based on what structure gives you the least number of loops that you need to iterate over its element to find a specific intent or to find a specific entity as well, right? So continue. So typically, if you're talking about data in JSON or the accounts which have in its dictionary username, password, and an email, these three values should map to the actual attributes or should map to the actual attributes or instance variables inside the entity class. So you should have here a username, a password, and an email, right? And we will have a couple of methods. Let's say that we have a method that is called setAccount. And I will tell you what exactly is setAccount is about, right? And let's say that setAccount is going to take some values. It's going to take some values, arguments from the user, which is basically a username, an input, for example, that's corresponding to that argument, a password. Maybe the guy is trying to create an account or is trying, let's say that this is going to be triggered or invoked whenever we log into the system, right? So typically you'd have a login method as well that's going to take the username and the password. So we will have the username and the password from login and pass it. If the guy is in the actual database, we are going to pass it into setAccount to actually set these values into specific values. So by default, all of them are none. So any object that is going to be created of account, by default, all of these values in it is going to be none. Right, so I pre-wrote a couple of stuff to illustrate the flow of what's going on, how is the code being handled from one object to the other. This part right here illustrates the class diagram in a nutshell, and this other part on the left, this illustrates the main script. That's the main.py, or some people call it bootstrap.py. This is where basically all of the object initialization happens and all of the imports happens, right? You can see here that I'm importing from the file that is called account, I'm importing the class account, and I'm creating an object of the class account in the main script. And underneath of this is where your program starts to take place. This is where, for example, if a command, I'm just writing something really simple here because it will not fit the whole screen, but let's say that the user enters a command like li, so he wants to log in, right? It's just equivalent to pressing a button that corresponds to login, right? So the user will be asked to enter username and password, so these variables are going to be used. These variables are going to be used in logging in. So as I told you, in the account class, we have a setAccount method and a login method, and we will also have a create account method, but I'm just ignoring this for now just to illustrate one point. And we have the logout method, right? So as I told you, login needs the username and password, and first it's going to check is that username and password is inside my intents.json, I'm sorry, inside the data.json, is it inside my data file in my database? If it is there, then I'm going to set the current instance variable of the current created account object to these specific username and password values, right? As we're going to see in a minute. So I'm going to take from the user in the main script the username, the password, and hence I'm going to call the method login on the account created, which is account1 from the class account, right? And I'm going to pass the username that I've taken as an input and the password that I've taken as an input to that login method, right? So before we discuss further what happens, I just want to illustrate one point, right? as I told you, you do not import the whole content of the data file that you are using directly into your entity class, or in this case it's the account class, but instead we use something called the database access layer. So the database access layer, or what we call, some people call it DB handler, stored files, some people also call it the DAO, or the database or the data access object. This is my main channel. This is my way of communication between the actual data file and the actual entity class, or an object of that entity class, if you may will. All right. So this data handler or database access layer, I didn't call it DB handler in the previous video, so I just want to be consistent. So I'm just gonna call it here what we call as we called it as stored files. Stored files, right? Before I continue, I just mentioned something and I didn't emphasize on why did I say that in the main PI, the initialization of each or all, or basically all of the objects happen in one place. It happens in the main script. That's to reduce what we call decoupling, right? So it is advised to have low coupling, right? But there's a certain trade-off here. Like if you reduce the coupling at some point, another point of your application or another side of the application can be a little bit highly coupled. And I don't think that there will be projects that it will all be low coupled. Some points, some part is going to be unfortunately highly coupled. If you find yourself having the import of one class inside another class, like for example this stored files class, if you find yourself in that accounts.py before the class definition, if you find yourself doing something like from stored file import stored file, right? This is an example of high coupling, right? Importing one class inside the other, or creating an object of one class inside the other. This is high coupling, right? So in order to avoid high coupling or to reduce coupling, we instead tend to use, instead of creating an object in one another, which is basically achieved by what we call composition. If you don't remember composition, just revise the video of implementing composition that I've released a couple of hours ago. Basically, composition is about creating an object inside another object. So object creation inside one another, this is composition. Composition is basically the one relationship in object-oriented that basically introduces the object of high coupling. It is what creates high coupling in the first place, right? So to reduce high coupling, we tend to convert composition as much as possible into association, right? Where instead of creating the object inside an object, instead of creating an object inside one another, we tend to create an object at some place and somewhere else. Like for example, I'm creating an object of whatever class of class A in object in main.py, and after I create an object of class A, so let's call it object A for example, after that object is being created in main.py, now I send it to class B, for example. I send it to the object of class B that is being created. So that's association. If you don't remember association as well, it's basically creating an object somewhere else and just sending that object in the constructor of the end class, right? If you don't remember association, please watch the video of implementing at least the first one. It will do the trick. Implementing unidirectional association, all right? Okay. So to reduce high coupling, to make the coupling a little bit less or low coupling, we tend to do association. So association is what I will be mainly using as a relationship type between my objects or between my classes. And how am I implementing that low coupling? How am I implementing this association is by creating the object at one place, which is really far from each of the class scripts. I'm just creating all of the objects in one main.py script, and then after the object is being created, it is sent to another object, and vice versa, right? And that's how you achieve low coupling in Python. In other languages like Java, something for achieving the low coupling is basically achieved by doing what we call the dependency injection, right? Which is, if you remember the solid terminology, it's the D in the solid, right? So it's the dependency injection. But in Python, we don't have dependency injection, right? So one would argue and say, all right, you avoided making the classes between one another, or the objects between one another, highly coupled. You made them low coupled. All right, that's cool. But if you look at the main.py, you will see that the main.py itself is really highly coupled. It's typically, if I don't have the main.py, all of the application will crash. So what is the point there? The point is that's actually the trade-off that we have. Like I told you, at some point, at some place, you will have some sort of script that is highly coupled, that is really highly dependent on every other class out there, right? But if you did this in favor of doing that, you will find that the classes are low coupled. And this is what I'm trying to achieve here. And in my point of view, in my personal point of view, this is better than having the classes highly coupled, but the main script is low coupled, right? So you're going to have every class and each other highly coupled, right? But the main script is low coupled. That's if you compare the two point of views, you're going to find that having the main script or the UI script highly coupled is better than having each of every class highly dependent on each other and on the other classes, right? Okay, so instead of dumping the data.json inside the account, like, let's just take a look at the account and understand what this means. So the class account has the constructor, the init method, has the self.username, which is this one, and has the PS or the password, and has the email. Initialize all of them as nuns, as you're seeing here. And it has the definition of the login method, this one. So what does the login do? It takes, as we saw here in the main script, it takes an input, which is the username and password, like that. What does it do with them? Well, it should check for example, let's say that we will not, most of the systems out there, it doesn't require you to enter a unique password. Like, the password doesn't matter, right? What matters is that the mail should be unique and the username should be unique. So let's take one of these approaches. Let's say that only the username in our system, for simplicity, is going to be unique. So I'm gonna take the username, right? And I want to search that given username in every account in the accounts, right? So what are accounts? This is the searching loop in a nutshell, right? But I want to grab every account from the data.py or the data.json, right? And search for every account in this accounts variable, which does not exist for the time being, and search for every account on the username. If I found that specific given username in the data.file, which is represented as the accounts here, then the user exists, and then I'm going to tell him that you are logged in, right? So the main question is, where is the accounts, right? Where is that account variable? Now let's say that the account variable is basically a class variable, like so, right? One would say, all right, I'm just going to skip this whole data layer access thing for the time being, and I need the content of the data.json. So I'm going to take it, right, and say that I'm going to say json.dump, json.load, which basically equivalent to read all of the content inside data.json. Read all of the content inside data.json and just load the whole thing inside the accounts variable, right? So everything inside data.json is in accounts. All right, now we get it. All right, now this will work. This will definitely work, all right? But the main downside to that is that this account class or account entity class is highly dependent on data.json. So basically, if anything happened to that data.json, maybe it gets removed for some reason, right? You will find that the account entity class is going to break. It's going to crash because you don't have anything to load, right? Or even if it didn't crash, right, it will just, the loop will never work, because if it didn't crash, say that we have something like data.json, but all of the content in data.json got removed and the file is literally empty. It doesn't have anything. So basically what is being returned there is an empty string. So if I'm trying to find something in for example, for whatever x in empty variable, right? The loop will never actually be executed. The loop will be skipped, right? So your application will be what we call not robust, right? Okay, so robustness is basically about, is the application easily broken or not, right? So if the application is not easily broken, then this is what we call a robust app or robust code. Okay, so that's robustness. All right, so broken doesn't necessarily mean that the app will crash or it will raise an error. It may not raise an error, but it can easily crash, like logically. By for example, if I don't, for example, if the content of data.json got removed for some reason, and this variable is found to be an empty list returned like that, right? So typically this loop will never execute, and there is no error that will going to be occurred, and I'm just gonna go to the next line, and every user who tries to log in, he will just get the message that you are not registered in the system and please log in. And that's not something that you want to do, right? So this is a logical breakdown for the system. This is a logical crash of the system, right? It doesn't have to be an error that has appeared to you, right? So a code can be broken either via a bug, like a physical bug, right? Or just a logical error where a loop doesn't work, or a file that you are reading does not really contain anything useful. It's empty, right? So that's what I want to say about importing the whole data.json content, inside the entity class. So typically loading the entity class like that, right away into loading the content of the data.json right away in my entity class, that would actually make it can make things a little bit inconvenient in the future. For example, if you have the data.json, it's a database file or a table or even a data file that is stored on a specific computer or a specific server, right? So what happens if that server goes down, right? So the server that holds all of the data files is down for the time being, and the server that holds all of the code is on another, or I'm sorry, the server that is holding all of the code is just another different server. It's a different computer, right? So if the server that holds the code for example, it has the code for class account, right? If that server is running and is trying to load the data.file that is existent on another PC like that, and the PC is currently down, this load will fail, right? So bottom line is having the entity class dependent directly on the data file is not a good thing. So that's why we tend to use a DB handler or the database access layer in the middle. So to lower the dependency on the actual data file between the entity class and the data file, right, we create that database access layer. So what is that database access layer? It's represented by that stored file. If you saw the previous video, you understand what this is gonna do, but let me just rephrase in the fastest way possible. And let's say that we have a memory variable and we have a file that is called stored file. This stored file will typically contain the string, the name of the file that you want to access and load the content from, right? And the memory is going to contain the actual whole list of dictionaries, the actual content, right? So this is going to contain the actual content inside that memory variable. So that memory variable is basically nothing more than a what we call a temporary variable that contains the content of the data file. Okay, and the stored file is just a link or a reference to the file name, which is in this case, if we're talking about data.json and accounts, it's data.json, right? So instead of loading the data.json directly into the entity class or the accounts class, we will do the following. Now note something here, that this account this account's variable is a class variable, and this class, any class variable, is defined in the area between the class name, class definition name, and the constructor. So it's in this area right there, right? So class variables are typically represented as a the variable name, right? And there's a line underneath, so they're always underlined, right? So this is a class variable, which is going to be existent across all of the objects that is going to be created out of that account class. All right. So let's say that we have all of the operations that I need to conduct in any file. Like if you have any file, you would want to read from that file the content, you would want to write stuff into that file, right? So let's talk about read and write for the time being. Let's just talk about read. And if you understood read, the whole point of all of this illustration will be actually proven, right? So let's take read, for example. Let's say that I have the read. Let's say that this is the class that is called class stored files, and there is the constructor. Okay, let's say the constructor, like whenever you create an object of stored files, the constructor asks you for the file name, right? And once you provide that file name, whenever you're creating an object of stored files, right, this file name is going to be stored inside the variable that we said its name is going to be stored file. That's a reference for our file name. And also we have the memory, and this is the most vital layer. Okay, so let me just indent this a little bit. Now let's say that we have the read method. It's a instance method, right? Since it has self and it operates on the instance variables, right? So these are the instance variables. I forgot here the self.memory, like that, right? So what does read do? Read is the one responsible for fetching all of the content from the data file that is being passed. So let's say that the data file that is being passed, its name has been stored in stored file, right? So I can easily open a stream or a channel to that stored file. There's no need from the string here. Open that stored file. There's something just missing in the mode of reading. I just want to read from that file, right? And let's call it F, for example, right? So after that file is open, I'm really concerned about just loading. Since it's a JSON file, I'm just concerned about load JSON.load the content of that F file, and I'm going to return the content that I have just read. Now the question is, to where do you want to return that content that have been just read, which is the content of the data.json, if we're talking about the data.json for this in this example, right? So that's the main actual connection that is going to happen here, right? So basically, read is going to return these contents inside the variable that is called memory. So basically what is happening is that the constructor, whenever you create an object of stored file, the constructor is going to execute the right hand side here first. Is going to execute the right hand side first, which is going to trigger the read function or the read method. And the read method is going to have that file name, right? Is going to have that file name that is stored inside stored file. Maybe I should have just made this line before the other, but that's okay. Okay, so the constructor is going to trigger the read function on the right hand side right there, is going to load all of the content of the file that we have just opened, which we have specified when we were creating the object of stored file, right? And is going to take all of that loaded content, return it, and dump it inside that memory variable. So now your memory variable is working as the actual content, the current temporary content of data.json. Okay, so every time I need to do anything, I'm just going to refer either to the memory variable or either to a function that returned to me the content of the memory variable. I know that this sounds a little bit complicated, but let me just rephrase. You can have the memory variable and access it as much as you want. And you can also have a function that is called, for example, getAll, that returns the content of the memory variable, right? So basically, we said that read is going to be the one responsible for loading the content inside the memory variable, which is going to be used all over the place, right? And the getAll is just going to be defined as simple as something like that. I don't think I have enough space to write this, but I'm just going to write it really briefly. So if I define getAll, I would say that is something like this, right? So getAll typically return the content of the memory variable. That's it, okay? Because remember, I told you before that interacting or actually accessing the actual variable of the memory directly or accessing any instance variable directly is not a very good design move, right? So instead, we provide an interface for that variable. So we provide the method to access the content of that variable. In this case, it's called getAll, for example, right? So where does the object StoredFiles that is going to handle the data.json is going to be created? This is the main question here, right? Now, this answer is simply in that empty area that we have left here for the accounts class variable. So inside the accounts class variable that we are going to traverse in the login method to search for the given username, right? Inside that accounts class variable, I'm going to say stored files, or we can call DV handler, and send. Look at the constructor of stored files. The constructor takes a file name, right? So we can send to that constructor, to that object of file name that we are creating, we can send to him the file name that we want to interact with. In this case, I want to interact with data.json, right? So once this is created, an object of actually stored file is created, and I'm denoting this part, this guy right there, by the object of stored file. So let's say that this is the object of stored file. Let's call it stored file object 1, right? Which we saved inside the variable that we called accounts. So this is the alias for stored file object 1, just because I don't want to use stored file object 1 all over the place. It's just not convenient to actually pronounce. So which is basically represented as the accounts class variable inside the account class, right? So that object have everything that the class would have, the template would have, right? So it has a memory, it has a stored file, right, which is basically in this case the stored file, which is the name of the file that is being sent. So it has data.json, right? And the memory would be triggered by the following. Notice that the constructor here of the stored file that actually gets triggered and gets executed the minute that stored file is being called, the minute that the object is being called right there, right? Which does the following. It takes the actual name of the file that we have sent, which is data.json, place it inside a stored file. Let me just make this by this order. Place it inside stored file, and then goes and execute the read method right there. So it executes the read method, right, on the stored file, which is in this case referring to data.json, and the read will load all of the content of the data.json, puts it in the variable instance method that is called memory, or instance variable, I'm sorry, that is called memory. This is what the read will do, like that. And so now the memory have all of the content of data.json, and this is what we can do to interact with the actual records in our system. All right. So this is the kind of object that is stored inside the class account. So any object from the class account is going to have a shared class variable that is called accounts. So this object, let's say that inside the main script, as you see here, I have created an object of account, right? So that object of account that is created inside main.by, notice here that the object of stored file will be created in the entity class. So any object of stored file will be created in the entity class. So this is the kind of relationship that we have, right? So I'm going to draw the relationship as association for now, and I'm going to tell you exactly what would that relationship be. Is it composition? Is it, you know, really association as we were saying, or is it something else, right? So, all right, so now the account that we have created from account, which we call account 1, is going to have a username that is equal to none in the first couple of phases that's created in, right, until we log in the user. So all of these are going to be none. Right, and it's going to also be having the class variable that is shared between all of the instances or objects of account class, right? So that's the accounts shared class variable, right? And so if you looked at this loop now this wouldn't really make sense, because remember the accounts class variable, which is basically an object of stored file, it's an object of stored file, right? So this loop wouldn't make sense. How do you say that you are traversing an object? That's just logically not true, right? So instead of saying that I'm traversing the object, instead of saying that, you would say that you are traversing the memory from that object. So from that object that we have created inside accounts, we are traversing the actual memory variable. I know that there is accounts first, accounts dot, because it's a class, it's a variable name, so it needs to take the class name, but I'm just doing this because there is no space. Whenever I code it, I'm going to correct this mistake. Okay, so instead we are saying that we are searching or traversing the memory from that accounts object, the memory from that stored files object, okay, which is typically containing that memory containing the content of the data.json that we have sent into that object while it was created, right? So inside accounts we have memory, inside accounts we have the memory variable that has the actual content of data.json. This is the whole point. That's the whole idea of what we are doing, right? So what is going to happen now is that we will say, if we found that account in memory, and one would say, why did you make get all if you are going to access the memory directory? That's correct, that's totally right. So instead of saying that I'm going to access a variable, an instance variable of some object directly, which is not something that's really good, right? We will use the interface or the method that we have created that actually returns the content of that variable, which in this case, the get all. Remember, get all will return the content of that variable, the memory, which contains all of the red stuff inside the sent file, which is in this case the data.json, right? So I'm going to say accounts.getAll. Now I have all of the accounts that I can traverse, which are existent inside the data.json. So if I found that username that I was searching in for, right? If it's found, then I'm going to call the set account, right? If it's found right now, then I'm going to call set account, right, to set the current user's info. So I'm going to take the username and password that has been passed into login. If you notice that login and set account take the same number, the same arguments exactly, because they are internally used inside one another, right? So I'm going to use the username and password that have been passed into the login method. that's just in case if we found that username inside the database, and we will call setAccount. And what will setAccount do? It will take this username and password, place it in the self.date username inside the actual variable of that object, of that created object, and place the password inside self.password, and it's going to search for the index. And I'm going to show you how we'll do that in the code. But basically, if you found the username, we will internally write some code that returns the index for that username. And since we have the index, right, then we can get the email and set the email as well, right? So once the setAccount has finished, now all of these nuns will be taken away. Let's say that the user entered the username here in the main script to be something like Ahmed, which is in this case it's in the database, and he entered the password as something like 123, which is as well in the database, right? So if the login method has been triggered, as you're seeing here, and if the search was actually returning true, if you found that guy inside the memory of the accounts universal or class variable, then if it's found, then I'm going to call the setAccount, and hence I'm going to take this username and set them in these instance variables. And in this case, I'm going to set this username with Ahmed. I'm going to set this username with 123, the ones that you have entered as inputs, like that. And I'm going to using the index that I found for that guy, which is the first index. This is index of 0, right? And set his user or email, like that. Okay. Right, and that's it. That's the whole cycle, right? So the question is, now remember just one thing, that created SF or stored file object 1, which we have stored inside the accounts, right? This is inside the account class, right? This object, which was created in this area here in the right hand side, has been stored inside the accounts variable, which is inside the account class. So it's inside the account class, right? So one would say, isn't this composition? Because, you know, that's object creation, right? So object creation inside a class variable or inside any variable, that's composition. So one would say, all right, this is composition, like that, right? It is not composition. It's going to be a create dependency. Why? Please refer to the guidelines video. Inside the guidelines video, I have a quick note on composition. If composition is used, or if the object has been compositioned, or I'm sorry, if the object is being created in an instance variable, then this is composition. If it is created in a class variable, then this is not composition. This is what we call a create dependency, right? And please refer to the videos that is called guidelines for this part, right? There is a video for implementing composition, but if you don't want to watch it, I just mentioned it in the guidelines. I think the guidelines is more important, right? So this is the class diagram so far. Let me just go to Lucid chart. Okay, so going back to the class diagram that we have created previously. Let's just make this a little bit relevant. So that's should be private variable. There is logged in variable. That's a flag. It's going to hold either true or false, but I didn't talk about it that much in the previous illustration. We're going to see it in code, and I'm going to remove reserved movies for the time being. All right. So we said that we are going to have a setAccount method. All right. Let's just make this public. Everything is public by default. So let's say that setAccount is going to have a username and password. And if anything changes, I'm going back to the class diagram, changes again, right? So we have setAccount, we have login, right? Username and password. We have logout, right? So logout doesn't take anything. And we will talk about create account when we code it. I'm not going to illustrate it because the idea is now, I think, it's obvious. So create account is going to take, I think, the necessary things to create account, which is all of the fields in the data.file, which is password, username, and email, right? So this is basically all of my methods. And stored files is going to have the memory, is going to have, that's where the actual content of the file that we will pass into the object of stored file that is going to be created inside the entity class, right? So that object is going to be, in the case of the account entity class, is going to be stored as a class variable, a class shared variable, right? That is called accounts. This is what we are going to use for searching when we are logging in, when we are creating an account, right? So this is a class variable. So I'm just going to underline it. And that's the stored file. Notice that these arrows don't typically mean anything. I was just using them to illustrate a point, right? So I'm just going to have these files or artifacts there. I'm going to lose this again. It was just for illustration. And that memory is supposed to be private, where I'm going to remove the search and update from this diagram for now. We are going to code it anyway, but let's just remove it for simplicity. And to return the memory, which is supposed to be a private variable, instance variable, I'm going to use the getAll method as we've seen in the illustration previously. And we have the stored file, which is going to have a link or a reference to the string name of the actual file, which can be account JSON, account data.json or data.json, movies.json, whatever the name of the file. And I think that's enough. Now the dependency that we're talking about here, or the relationship, is it going to be composition? We are going to create an account of, let me just put the data here. So this is going to be an object of the stored file class. It's going to be an object of stored file class, right? And notice that this can be called DB handler as well. There is no difference. Okay. So it's an object of stored files, right, which is going to have an argument of data.json, right? But this is not going to be composition. Come on, this is not going to be composition, since it is stored inside the class variable accounts, not in an instance variable like these guys. So this is going to be a string, or let me just put this as an integer, and this is string, and this is going to be a bool or a boolean, like so. And set account is going to, I'm not really sure about how this is going to be implemented, but let me just say it's going to be returning a string that represents that the user has been logged in. Login is not going to return anything. It's just going to call or let me just leave the actual return types for the time being, right? Let us see how we will code this and return back to the class diagram and modify it afterwards, right? So memory is going to have the return from the read function, right? It's not going to, there's no, the class diagram is not written like this. I'm just saying that's going to be having the content of the read file, right? But anyways, it's gonna have some data type. Mostly if I'm using a list of dictionaries, all of these guys, so it's gonna have a list like so, right? I don't know the number of elements of it. And stored file is going to have the string, the actual name reference for that file that has been passed onto the object when we create it inside the entity class, which is in this case account. And that's not composition, as we said. This is dependency. Where is the actual? Where was the line from? Where do we get the dash from? Yeah. And we have the stereotype create, like that. And this is the class diagram so far. So let me remind you of my work environment. I have that folder. I called it CRS version 3. I have inside of it the folder that is going to be containing my actual classes, which is CRS. And I have a testing folder that has pretty quick stuff to test using the Jupyter notebook that I'm having opened here, which is test version 2. So let us create the stored file here, then put it in a Python file and put it in the actual project folder. So this is the stored file class, right? So let's say stored files, right? And the constructor would have, it will take the actual file name, right? And that file name is going to be stored inside stored file. And since we have the file name, we are going to initialize the memory as so, right? And that memory is going to take the content of the red the red content of the actual file, right? So let's define read for the time being and see, right? So that read is an instance variable because it is an instance method because it operates on instance variable, these instance variable. So it's gonna use the internal stored file and open it. Self.stored file. In the reading mode, I'm going to store this in a variable. So store this opened file in a variable that is called a file, right? And then I'm going to use the JSON module. So I'm going to import the JSON module to actually say JSON.load the content is inside that a file, and I'm going to return it. So this is going to be returned and saved inside memory when the constructor is executed, when the object of stored files is being created, right? So notice that this is an instance method, so you need to say that this method is an instance method, so you're going to find it in the current object's pool of variables and pool of instances, right? So let's say that we have a write method as well, and we currently do not know what kind of arguments, what kind of things does it take, and what it returns, right? So I'm just gonna have this as pass for the time being. Okay, and let's try the read for now, right? So let's create an object of stored files and see. Let's say stored file, which takes a file name, which is in this case I have it as data.json that has only one user, one record, one tuple. So I'm going to send data.json, and notice that this needs to be surrounded by brackets or double quotes, I'm sorry. And let's call this object something like accounts or sf object 1. That's just ugly, so let's call it accounts. Alright, so let's create account. Now account is created. Now let's take a look at the actual memory in that account. You're gonna find that the memory has the actual objects in the data.json. I'm gonna remove the reservation for now since we don't really need that, right? I'm going to recreate that object, and now the memory has this list of dictionary. Let me try and print it. There's no difference here, right? So instead of accessing the memory directly, I can have something that is called get all, right? So get all should just return the actual memory content. Return self.memory. That's just to replace the actual accessing of the instance variable. So remember that was supposed to be a private variable to begin with. I could have done that, but the name mangling wouldn't really matter in Python. So anyways, let's just say that we have a method that get me the content of memory. So now I can just use get all to return the actual content of the red data.json, right? And now let's go and create an account, right? So if this is ready, how about we put this in my actual project folder. So let me go to the project folder and create a class and call it stored files, right, .py. So stored files.py is going to have my actual definition of stored files class, right, and that's it, right? But it needs to have the stored file or data.json from the folder that is called testing inside my actual project folder. So I'm gonna put it there, right? Okay, so just as a safe check, I'm going to write some driver code. Note that I'm going to remove it. You do not have a driver code in your classes. Remember that there is no driver code in the class definition. The only driver code that you have is inside the only driver code that you have is inside the main.py, where the initialization of all of the objects happen, right? So let me just try this for testing and let's see. Now I want to create an object to stored file and send data.json, which Python will refer to the current folder to search for data.json in, right? So now we have what we call, let's call this accounts, right? And let's try to say accounts.getAll, and let's try to print what this will return. Now it's gonna tell you that I cannot find that file, and that's expected. I'm gonna tell you in a minute how can we solve this. Now there is a slight problem with the Python interpreter. Whether you are using PyCharm or Visual Studio Code or whatever, it tends to find or it tends to search in the actual directory that the terminal is opened in, meaning that notice that my terminal is opened in the CRS version 3. So the terminal is currently is operating in this level. So it is trying to find in this level, under this same level, right away, it's trying to find a file that is called data.json. If you look closely, you're gonna find that there is 3 folders and none of them is data.json. It doesn't know that data.json is inside another folder that is called CRS, and it's really showing from the actual header right there. So the stored files is inside CRS, that is inside CRS version 3. So the terminal is open in the outer level. So we will need to actually access the CRS folder, like I want to have something like /CRS, right, in order for this to work, right? So if I try to kill the terminal and run it again, maybe this would work. No, it didn't work. It opened for you the terminal in the same directory. So you can say cd CRS and try to run the code again. In this case, it will work, but the problem here is not with the file. It is with the actual misspelling that I did. So it's going to return all of the content. Now this is one bad thing to do, which is basically relying on the terminal to figure out where is the file located. You need to write some code to actually get you the path of the current working directory. So how can you do that? One thing you can do is the following. Let's just kill that terminal and let's run it again. Unfortunately, it's going to always put the terminal in the first level, in the first directory, in the CRS version 3, not inside that one. Well, I'm going to tell you something. If you have your working directory, if you have your code right away in that folder, meaning that, for example, you have your code inside the folder that is called CRS, then good for you. You would not have that error popping, right? But I did this kind of structure. I have this file inside this folder. Inside this folder, I did this on purpose to show you that this error can be actually be happening. If it didn't happen in your machine, it can happen on one of your teammates' machines. So the one who is implementing this code needs to take care of this. So how can we take care of this, right? One solution to that is the following. Let's go to the actual file in the File Explorer and see its location. So data.json, if you click on properties, you're gonna see that it is stored inside this directory. So I can just copy this, right? And instead of saying that I'm trying to open data.json, I'm going to be more specific and I'm gonna say I'm trying to open up data.json, right? That is inside the folder CRS, that is inside the CRS version 3, that is inside the driver or the drive T. When you run this, this is gonna work. All right, but I don't really like that for one reason. Whenever you are giving this piece of class to some teammate of yours, maybe the data.json is stored in his machine in the current working directory C, or for example K or whatever, and maybe it is inside another folder that is called something like new folder. So every team member will try to modify this current path in order to access just the data.json, which is something really trivial, and it's really annoying to every time to modify it, right? So one tweak for this problem, one fix for that problem. First of all, before we talk about the fix, just a pro tip: do this. All right. Do this just in case, just in case, because sometimes you know that the actual backslash is basically, if the backslash had a character afterwards, sometimes you would find Python trying to interpret this C as a special character, something like backslash n. Maybe it's going to understand this backslash n as backslash C, right? So all of this part will be gone for you, right? So you have this rs, and you're gonna have either an error raised that there is nothing called /c, or another error will be raised as there is no folder that is called rs. So always have double backslash, right? It's not gonna hurt, it's gonna work the same. Now let's go to the main fix here. All right, now the fix to that is doing the following. We have a library that is called OS, which stands for operating system, and this operating system is basically the kind of Muppet master that can tell you any where is any folder is located, or where is any file is located, right? So it's gonna return to you the path of the current file, the path of the current folder, and so on. So how about I do this? How about I say print operating system dot path dot what was it? Operating system dot path dot, I believe, what was it? Was it directory name? No, it is, yeah, it's real path. Yeah, it's real path. Now we will send to this real path method the actual file property. There is a property called file. If you remember, a property called dict, right, that we have discussed before, that's a dunder property. That's the same thing. File basically is saying that I'm going to give you the path for the current file, the current script that you're in, which is the StoredFiles.py, right? So let's try and run this. This is gonna tell you that the StoredFiles.py is inside this path is inside your D driver in your machine, is inside the folder CRS version 3, is inside the folder CRS, and that's your file, right? Now what we really care about is the actual folder. We care about the container. We don't care about the file name, because typically the file name, that's the last thing I care about. I just want to get the actual folder, right? So how can I get the actual container? Right, so if you did something like this, let's say operating system path dot dir name, or directory name, directory is the same thing as a folder, by the way, and send the file, the path file, like that, you're gonna get the actual directory. Okay, that's what we need. All right, regardless of the file name, which is stored.py, I just want to get the folder, because if this is being ran on other team member machine, I just want to know where is he storing data.json, where is he storing stored files.py, and hopefully these two are in the same directory, these are in the same place, right? So what I will do, instead of doing all of this, I'm just gonna stick to the main convention here, which is passing the file name, and I'm going to take care about the rest of the commands, right? So you know that this is gonna return to you the current working directory, which in this case, in my case, it's in the D CRS version 3 CRS, right? So I'm just gonna take this and put it in a variable before the class begins, like that. This is gonna return to you this guy right there, right? So once this is returned, what I will do is that after I take the file name, when I create the object of stored files like that from the user, or from the programmer who is using this class, I'm just gonna say that I'm going to concatenate that folder directory plus, you know, that there's gonna be a slash right there, so right? So I'm just gonna put 2 backslashes plus the file name, and that's it. Okay, we don't really need to care about any of that anymore, right? So if you run this, operating system is not defined. All right, that's it, it works.